This is a continuation of our INAV video series for the Cobra, the on-point Cobra. You have finished your assembly, and now we are ready to plug in and hook up and walk through some of the configuration. This video is purely here for your information to get you familiar with INAV. Every Cobra is pre-loaded and bound and gone through and checked and everything before it leaves our office. So there will be some things that I show you in this video that you will not have to do, but I want to go over basically as much as possible for any particular chance that either you lose configuration information, or if you decide you want to maybe try Betaflight for a little while and then you want to move back to INAV. This is really just a walkthrough of each one of the tabs and configurator, the INAV configurator, so that you have something to reference if you wanted to dive into this. You will do some of this because you will need to check your motor rotation as well as do your calibration for your accelerometer and your compass. And then lastly, you'll also find that some of these things you have to have a battery plugged in for, and some of them you do not. So from that, I'm going to jump right into this. Some things I want to point out. This up here, this is what it looks like before plugging in. When you plug in, you will hear the USB tone and it will change to a COM port. So that shows that you are connected. There may be other COM ports available, so you'll need to make sure you select the proper COM port. And then once you have once you've noticed that, the other thing I want to call your attention to is this over here, this show log. I always have that expanded because that gives me information that can be useful. For example, the configurator that I'm using, the INAV configurator version. And then right here, it gives the version of INAV that I am using. And then right here, it gives you the board, the flight controller board that I am using. So this all is going to have useful information that you'll want to see. So I'm going to go ahead and connect. You will not get this default values right here. Again, I will have done most of this. So this is where I click. You will not see this unless you have changed your firmware and have flashed it with something else and are returning back. So I'm going to click this. It's going to add some default settings that are specific to the board that I am using, the flight controller that I am using. So we'll wait for this to pop back up. Okay, so we are now back and connected. I'm going to go ahead and flip over to this calibration screen. You will see that we will have to at some point calibrate our accelerometer, calibrate our compass. It doesn't know we have a compass right now because we need to tell it. I'm going to come over here to Mixer. Mixer is basically what shape quad are you doing? We are doing the generic quad X. So I'm going to tell it to load and apply because of the fact that this is already set to that. All we need to do is that. Warning, action overrides. So that's fine. Save and reboot. And it will make those adjustments. Again, I'll keep saying it over and over. You will not be doing this specifically. This is purely here to show you if you ever had to do it from square one. So now we have our motors 1, 2, 3, and 4 set in place. We can move on to our next tab. Outputs. So for this, we need to enable our motor and servo outputs. The protocol that our ESC uses is actually a DShot 600. And then I actually bring our motor idle, down to about 8, just because it throttles up a little bit sooner. You're not waiting as long. That's all the adjustments that I make on this tab. I'm going to save and reboot. Okay, so everything is saved. We're going to move to our ports tab. Our ports tab, there are a few changes we make. We uncheck this and we come over to peripherals. UART1 is our ESC output and telemetry. UART2 is our TBS smart audio. UART3 is not used. UART4 is our control link to our remote control. And then UART5 is our GPS. So if you ever come to this tab and it does not look like this, then you will know that something's been dumped, something happened, somebody changed something, and you need to go back to these settings here. I'm going to click Save and Reboot, and we will get ready for the next tab. Okay, so we've done our outputs. We've done our ports. Now we're going to come over to configuration. Our configuration is here. You'll see right now there's no magnetometer. Magnetometer. It's hard to say. And that's because we do not have our GPS set up. We do not have a battery plugged in. So we could sit here and put that at auto, but it really isn't going to matter until we wind up adding a battery to this. So I'm going to leave it as is because there are a few other things we want to look at. If you ever changed your alignment, if you rotated the flight controller or anything like that, this is here where you would do that. We do have a GPS, so we're going to enable that. We're going to come over here, personalization. That is something that if you want on your on-screen display, you can list your craft name. We normally put on point, or the INAV Cobra, INAV Cobra 1. Okay, and then the other thing I'm going to point out is this VTX. Basically, this is telling you what it'll boot up into. The only time this would be different would be as if you've actually changed your channel through Smart Audio. But in most cases, when you boot your drone up for the very first time, it will boot up onto Fat Shark as the band Channel 1, Power Level 1. That should be it here. Your connected hardware allows for it. Ours does. Don't want to miss that, so I'm going to set that there. And then lastly, before leaving this tab, I'm going to hit Save and Reboot. So you see our magnetometer is actually red now because we told it auto, but then because we did not have a battery plugged in, it did not detect it. So that's why that is red. The reason the GPS is red, we told it we have one, but again, no battery is plugged in, so it doesn't see it. So that's why that's red. So we'll come back. Basically, I'm going to walk through these, and then we'll come back and do all the battery required settings all at once. So I'm just going to keep moving through here. Fail safe. We set ours to return to home. I hit save and reboot. there are capabilities to adjust the speed and how the return to home works. Stock settings are perfectly good, so therefore we leave them as is. I'll show you here in a little bit where you can make those adjustments. But for return to home, that's how we have it set. So that way, if for any reason you were to lose your connection, it would return to home. But then we also put it on a switch. So that way you can make it come back if you so choose. PID tuning. Again, stock PIDs are actually really good out of the box. The one thing that we do change is over here on the rates and expos. 300 tab, 300 tab, 300 tab, 30, 30. Those are the settings that we use. Now, why do we change this? Racing is a little challenging. You don't want a super twitchy quad. So you're lining up for your gate. You're getting ready to race. You're lining up. You're trying to make sure that you make it through. When the rates are high, the drone responds more aggressively and is a little twitchier than we would like. So we tone them down. We drop down the numbers a little bit to try and slow it down a little bit, make it easier to line up for those gates. So when you get your Cobra, these are the rates and expos that'll be set. Save. We're looking up here. EEPROM saved, PID tuning. So now we can move on. We don't really do anything in the advanced tuning. Another reason that INAV is useful, or INAV is attractive, is it's used for in airplanes, but it's also used for rovers and boats and many other autonomous applications. So becoming familiar with INAV would benefit you not only from a drone perspective, but for rovers and any sort of robotics type activities. INAV is definitely a good platform to go with. Your advanced tuning is where you would go if you ever needed to make adjustments to some of the navigation settings. So for example, your return to home settings are located in the advanced tuning. Your multi-rotor navigation settings are here. Speeds, waypoints, how fast it ascends and descends. These are all settings that would be in your advanced tuning. The programming tab is if you were doing a rover or a boat or a robot of some kind. This is where you can actually punch in code or instructions, commands, if something happens, do this, that sort of thing. Receiver, right now, I do not have my receiver turned on. So right now, this is what it would look like if you were not bound to your drone. Now I'm going to turn my receiver on, and you will see this is what it looks like when you are bound and everything is connected up properly. So we're good there. We're going to move to our next one. Now, right now, our modes are not set up. This is what the switches are. We will visit this twice, once without the battery and once with the battery, or you can ignore this tab now and come back with the battery, which I think is what I will do. No point in setting it up twice. Adjustments, not necessary. You can always come back in here and make adjustments if needed. Your GPS, again, is not going to give you any information at this point because we don't have a battery plugged in and we're inside the building. We're not going to get a GPS signal. Mission control. This is where you would set up mission planning if you so chose to do it. We do not cover it in our Cobra instructions. The Cobra is tailored more towards racing, and therefore, instead of mission planning capabilities, we give it turtle mode capabilities, which makes it possible for it to flip over in case of a crash or something like that while you're racing. We sell a larger 400 to 500 millimeter class drone called a Hawk that we are starting to package with INAV. And in that bundle, we focus more on waypoint and mission planning and how to go about doing that. But this is where you would go to do that if you were using that. On-screen display, this is what you see on in the goggles. When you put your goggles on, this is what you're going to see. It actually is laid out a little bit different. So I'm going to go through and change this. Usually I find it easiest to go through and uncheck everything, with the exception of the system messages, because that's where I kind of base everything else around. So let's say you're at the field and you go out and you plug in and you want to fly, and for some reason it is not arming. You want to put your goggles on and take a look at what these system messages are telling you, because that is the fastest and easiest way to see what's going on with your drone. So I have a blank slate right now. I'm going to come through and make the options that I use. I usually use the battery cell voltage because I don't like math. We send out our Cobras with a 3-cell battery, but if you happen to use our Scout drone, that uses a 2-cell battery. If you ever got into any bigger drones or used larger batteries, you'll find that they come in 5-cell, 6-cell, 4-cell, many different sizes of drone batteries. So I have learned that the easiest way to determine the voltage at what point I need to return is to just have a single cell, because then I don't have to figure out, okay, do some math in my head and okay, now it's time to come back. All I need to know is what a single cell top and bottom voltages are, and then it doesn't matter what battery I plug in, I always know when I need to come back. Which, that information, a fully charged single cell is going to be about 4.2 volts. And a depleted, fully used single cell is going to be about 3.5 volts. So as long as you come back somewhere around the 3.6, 3.5 setting, you know you are taking good care of your batteries and not over depleting them. So I put my battery voltage right there. You'll also notice, I don't know if you did, but you can drag these around. It's a click and a hold. So a click, hold, and drag, and I can put it anywhere on the screen that I want to put it. I use craft name. I put that up here. Like I said, that's if you ever wanted to be Maverick or Goose or have some really cool call sign. This is where that's going to go. Fly mode, that's telling you if you're in acro or horizon or angle mode. These are flight modes that give you assistance in keeping it level and straight. Let's see what else. We use the heading graph so that you know where you're going. This is a little compass. I like to do GPS speed. I put all my GPS stuff on the left. We need altitude, GPS satellites. I put all that information over there. Distance to home. I'll put that over here. Direction to home. I like to keep that with that. And video. I like to put that. So in most cases, this is what your OSD is going to come to you looking like. Now, as you've seen, you can go in here and change this. I'm going to save. And then over here, it says OSD settings are saved. But again, like I said, this is how I send them out and the why behind it. But at any point, you can come in here and change them if you wanted to. The other thing we do, we like to race. We do have lights. So what we want to do is this. That color will go white. Save. And as you can see up here, LED settings have been saved. So now we've gone through almost all of them. There's a sensor tab. You can come in here and track the frequencies, how much noise, that sort of thing that's coming in on each one of your components. Black box, this is you can record the same information and then extract it out into other programs that will help you tune out noise in your setup. The CLI, this is kind of like DOS. This gives you the option to do direct command prompt entry mode into the flight controller. So this is where you would do that. I'm going to type in exit and it will reboot. So those are the main tabs. This is the before battery plug-in. I'm actually going to disconnect now and disconnect from the laptop. And now I'm going to come over here and plug in my battery. And now I'm going to plug back in, connect back up. So our GPS is blue, but as you can tell, our magnetometer is not because it did not save the settings in the config because we didn't have our battery plugged in. The other thing you'll notice here in the prearming checks, navigation is X'd out as well as accelerometer calibrated. So this is a nice handy way to tell you, what you have left to do. So first thing I'm going to do, I'm going to save calibration for last. So we're going to come through. We don't need to touch that. We don't need to touch our outputs. We don't need to touch our ports. Our configuration, we do want to change this. I'm going to put it on auto, and then I'm going to have save and reboot. Okay, so it is rebooted, and now you can see that our magnetometer is now blue. And it has it listed here as the QMC 5883. So now we have all blue across here. If we were to go to our setup, we still have some other issues that have popped up. We still got to do our calibration. We still have to do navigation as safe, runtime calibration. Let's come back here. We're skipping that for right now. Configuration, that looks good. All this looks good. All right, so something else I want to look at. Our failsafe was okay. PID, programming, receiver, modes. Let's do our modes real quick. And just to come back to our receiver, so pay attention. You got channel 5. That on your remote control is the leftmost switch, or SA if you're looking at your remote control. This, channel 6, is SB. the 3-position switch. Channel 7 would be SC, another 3-position switch. And channel 8 is SD on your remote control, and that is a 2-position switch. So we'll come over here to modes. First, we'll do arming. Arming is already set to channel 5. If you flip the switch, you'll see it moving around here. So what we want to do is we want to drag that over, and now you see you will be able to arm. So next thing we want to do, we want our flight modes. We're going to have it start. We'll give that channel 6, 3-position switch. We will have you start an angle, and then horizon we'll leave in the middle. So by doing it this way, when you turn on your drone for the very first time, you're going to be in angle mode. Then if you want to, you can move to horizon mode. And then if you have gotten really good, you feel you're ready to take the leap, you can go to nothing at all, which equals rate mode or acro mode. And that is no assistance whatsoever. So those are that. Now what we need to do is get into our navigation modes. This will be channel 7. 7 is our other 3-position switch. So the way we do this is we leave this first section here empty. We have return to home on 7, and we move that to there. And then we actually have this guy who's also on 7. So that position hold and altitude hold are combined, therefore giving a better stability and position and altitude hold in use. So now we see if you use the 3-position switch when you go to the middle, you've got position hold, alt hold. And then if for some reason you want to return to home, you just move to the next position and return to home is triggered. So that's channel 7. And then lastly, we do turtle. Turtle, we give channel 8, and we slide that over. That's the last switch, and that's the other 2-position switch. And that gives you turtle mode. Now we have our mode set up. We can hit save. We heard a beep, and you can see that the EEPROM has been saved. So now our modes are in good position. Now what I want to do is our outputs. We need to check our rotation. So this is what it should look like. This is what your motors should be doing. Here, I understand the risk. Propellers are removed. So don't do any of this if you have your propellers on. We are going to be spinning up motors. We are making changes to your flight controller. Anytime you ever do anything like this, you do not want to have your propellers on. So we have our propellers off. We're going to test our rotation and make sure that we are rotating our motors in the proper direction. You can do this one of 2 ways. You can do them individually, or you can spin them up all at the same time, whichever you find easier. For me, I usually do it one at a time. I think it's a little bit easier. Spinning them all up all at the same time just, it makes me nervous. I don't like having them all spinning all at the same time sitting on my desk. So I like to do it one at a time, but you can do it either way. With that said, I'm going to come over here. I'm going to uncheck this, or I'm going to check it. Then I'm going to do a simple click on number 1 and use my arrow keys to spin up the motor. Okay, so at 8%, it started spinning up. I'm going to put my finger along the side of the motor on the bell to where I know I'm not going to hurt myself. And I'm going to try and determine which way that motor is spinning. So the way that I can see right now, number 1 is spinning the proper direction. So I'm going to use my arrow key to bring it back down to 0. and move to my next motor. So now I'm going to move over to number 2. I'm going to spin it up. It should kick in right at about 8%. And same thing, I'm just going to touch the side of the bell to make sure that it's spinning the proper way. And for me, number 2 is not spinning the proper way. So I will need to adjust that. So I'm going to bring it back down. Then I'm going to come over to 3 and do the same thing. I'm just going to arrow up until I get to my 8%. And then I'm going to touch the side of the motor. Number 3 is spinning the proper way. So I'm going to arrow back down and move to number 4. Arrow up to 8%. Motor spins. Touch the side of the bell. And that one is correct. So out of all 4, the only one that I have is number 2 spinning the wrong way. So I'm going to uncheck. And I'm actually going to disconnect. I'm going to go to setup. I'm going to disconnect. I'm going to unplug from the computer. I'm going to unplug my battery. And I'm going to change 2 wires on the number 2 motor. By swapping those two wires, you're able to change the direction of the rotation of the motor. So I'm going to do that now. And now I'm going to plug back in and plug back into the laptop. Then I'm going to go back to my outputs. This time, I'm actually going to spin them up all at the same time. So that I know that I have them all correct. All right, they are all spinning. I'm just going to sit here and check. 1, 2, 3, 4. So they're all good now. All right, arrow back down. So our motors are rotating their proper direction. Our switches, our mode switches are all set up. The last thing we want to do is calibrate. So now note, if the flight controller is mounted in an angle or upside down, do the calibration steps with the flight controller pointing as shown in the pictures, not in the quad. Just pointing that out. Ours is not changed in any way, so you should be fine. You're going to click Calibrate Accelerometer. It says place flight controller in a position shown in the image, then press Calibrate button again. Repeat for each of the 6 positions, keeping stable during calibration. So, okay. It is sitting flat, so I'm going to calibrate. All right, and as you can see, we're good. Now, if I turn it upside down, and we're good. Change where it's facing to the right. We're good. Pointing up. To the left. And down. Accelerometer calibration finished. Check if values have been saved. Okay? And the values it's talking about are down here. And so that is how you calibrate your accelerometer. Now, I'm going to read this one, but I'm going to have to make a separate video on what it actually looks like to do this because it is somewhat of a visual type thing. But basically, you have 30 seconds to hold the copter in the air and rotate it so that each side, front, back, left, right, top, and bottom, points down towards the earth. So, like I said, I'm not going to do it right now, but what you will do is you'll hit calibrate compass, and then a timer is going to start counting down. And you'll pick up the drone and you'll just rotate it in every possible axis that you can in that 30-second time period that it gives you. Then you're going to click save and reboot, and you're going to exit out. So at this time, I'm going to go ahead and do save and reboot without this so that I can make the video a separate video doing this step here. Once you finish doing your calibration of your accelerometer and your calibration of your compass, you should be in good shape to get ready to go fly. But I'll touch on that on the next video. This is everything that you could possibly encounter with the INAV flight controller software. And then, of course, like I said, a majority of this will already be done before you get your drone. The steps that you're going to wind up having to do will be checking your motor rotation, and then doing your calibration, your accelerometer calibration, and your compass calibration. Your modes, which we did, will already be there. What I have is I have something called a diff file, and that saves every setting that we use. So in the event that you ever lost configuration and didn't have this video to help you set it back up, we can also send you what's called a diff file that will load it all, or a majority of it anyway, for you. But that's it for this one. Next video should be going over compass calibration. Then I also want to make a video concerning turtle mode, how to do it, and then make a video on smart audio. And with that, if you have any comments, questions, please put them at the bottom of the video in the comments section. Please subscribe to our channel so that you get any updates whenever we put them out.